Okay, we're just going to look at sketching trig functions. Now, I'm just going to run through our three basic sketches, which is y equals sine x, y equals cos x, and y equals tan x. Okay, so when you're sketching this, if you put in x equals 0, sine of 0 is just 0. So that means the sine graph starts at 0. Sine of pi on 2 is 1, so sine 90 equals 1. So that means then the y value will go up to 1. Then if you put in pi, sine of pi, which is 180, is 0, so it comes back down to 0. Sine of 270 is minus 1, so down there at minus 1, so it goes between 1 and minus 1. And then sine of 360 will go back to 0. That's there. So your basic curve will look like this. So it starts at 0, goes up and down. And if you kept continuing, like that would be minus pi on 2. This one here would be minus pi. But what we could say this graph does is it oscillates. So its period, it takes like 2 pi to repeat itself. So it takes, that's how long it takes to repeat itself, which is 2 pi. And we call the amplitude is how far above and below the x-axis this is. Okay, that would be your amplitude. So your amplitude here is 1. Okay, y equals cos x. So y equals cos x. So if you put in x equals 0, cos 0 equals 1. If you put in x equals pi on 2, cos of 90 equals cos of 0 equals 1. Cos of 90, which is pi on 2, is 0. Cos of 180 is minus 1, so it's down there. Cos of 270 is 0. And cos of 360 is back up to 1. So it'll go back up to 1. So that's 2 pi, 3 pi on 2. So your basic curve just starts here and it oscillates like this. So it oscillates just means it goes up and down about a central position, which is like, in this case, it's the x-axis. The amplitude, this one does have an amplitude. It's how far up above and below the x-axis it is. So the amplitude for this curve will be 1. And the period, how long it actually takes to repeat itself. So if you go like this, you can see by the time it gets to 2 pi, it starts to repeat itself again. So the period is equal to 2 pi. Now the tan graph, y equals tan, I'll just put it down here. We'll just have a look at that graph. So if you put in x equals 0, tan of 0 is 0. If you put in x equals pi on 2. Now, when you go to put tan of 90, you'll actually get an error in your calculator. So I want you to think about tan of 90 for the y value as sine on cos. So it's sine 90 on cos 90. Now, sine 90 is 1, but cos 90 is 0. So can you see you are dividing by 0? What this means is at 90, it is actually an asymptote. Okay, because it's going to approach infinity. So if you keep getting something closer and closer and closer to 90, you'll see it'll get bigger and bigger and it'll approach infinity. If you did the same for minus 90, you would get exactly the same. Then you go to 180, it'll be 0. And if you plot something either side of 180, you'll find that it just gets bigger and bigger and bigger until it gets to 3 pi on 2. And then it starts again. So what's actually happening here the period here is how long to repeat itself. It repeats itself after pi in this graph. Okay, this one does not have an amplitude because it doesn't do what we call as oscillate. It does not oscillate about a central position. It just keeps going up infinitely or down infinitely. Okay, so just a quick summary. We've got y equals sine x. So the sine graph starts here and just looks like that and goes from pi to 2 pi. Period is 2 pi. The amplitude is equal to 1 because it goes 1 above and below the centre, which is 0. So this is your x and this is your y. So we say that this graph oscillates. So if you had y equals cos x, it's the same thing, except it starts at 1, because cos 0 is 1. So it's doing that, it's repeating itself after 2 pi, that's pi there, that's pi on 2, and 3 pi on 2, that's x, and that is y. Y equals tan x, you get pi on 2 pi, 3 pi on 2, and 2 pi. So at 90, and that's minus pi on 2, and at 270, if we put the dotted line, that's where its asymptotes is. At 0, 180, and 270, that's where it's 0. And it just goes like this. Okay, and that's your 3 basic curves. Now, I just want to extend on this, and this will apply to any functions that you look at. So if you have a, f of a minus b, and then plus c, what impact do all these constants have? Now, this plus c here, that means you just go up c. If you look at the a is a dilation, okay? So it's what we call a vertical dilation. And it'll be towards the y-axis if a is greater than 1, and away from the y-axis if a is less than 1. So for example, like a half. Less than 1 but greater than 0. Okay, and if that a was a negative, then it just flips it in the x-axis. So this will actually be the same for any graph, even if it's like a trig graph. Like, so I've got y equals 3 sine x plus 4, we'll make that a minus. So this same rules apply. So here's your normal sine graph, so that's 2 pi pi and minus pi. Now, because we have the minus in front, the graph's going to flip. So that's the flip. And it's going to go from 3 to minus 3, because that's the dilation, and that's going to end up being your amplitude. And this 4 here just means it has to go up 4. So we've basically got exactly the same graph, except it goes up to 4. I'm not going to fit that in there. I can see that already, so I'm just going to redo that one. There you go, 0. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There it is there. Okay, so we're doing this same pink graph here, except we're going to be here, and it's going to go like that, and that's your 2 pi, your pi, and minus pi. Okay, so because it went up 4, so put a 4 there. Okay, now I just want to talk about, like I've talked about what's outside the function and the effect that has. So, you know, if you have 8 cos 4x, sorry, not 4x, we're just looking at shifting up. So x plus 3, that means that its amplitude equals 8, and it will be shifted up 3. Okay, so that means that it'll actually go between, like if you go, it's going to be 1, 2, 3, that's going to be that point, and you go up 8, so that's 11, and then you're going to go down 8, 1, 2, 3, and then 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, so it's at -5. So it's your normal cos curve oscillating about that point, but it's got to go down to -5. And the amplitude here is 8, because it goes up 8 and down 8 around the central position that is there. Okay. Alright, so now if we're going to look at what happens, first of all, if you put like 2x, okay, and let's put 3 there. So this is your normal sine curve like that. Goes between 2 pi and pi, pi on 2, 3 pi on 2. Okay, so the effect of that 3 would just mean that this has to go from 3 to -3. And your amplitude here would be 3. Now your period for any sine graph is 2 pi on n. And the n is the number that is in front of the x-axis. So the n here is 2. That means this graph is going to have 2 pi on 2, which is pi. So that means this graph is going to repeat after 2 pi, but because it's dilated, like this number in front here, this 2, it is a dilation by a scale factor of 1 on 2. So it'll be half the size, and this is horizontally dilated. So you go times 2 on 2 times 2 and then on 2. So it actually ends up just being a period of pi, and that's 3 and -3. And see, that's pi on 2 in the middle there. So it just squishes it like in that way. Okay, so the last thing I just want to talk about is if you've got a function like this, okay, so you've got that inside your function. So when you go to sketch that, you can do it 2 ways. You can move b to the right, so that's what the b does. That's your first step. And then once you've done that, you can dilate by a scale factor of 1 on a. Okay, so you actually divide by the a. And the overall shift on this, like if you moved it to b and then you went b over a, the overall shift would be b on a to the right. So it's not just the shift of b, you've also got to dilate it by the a. So let's just look at 2 sine 3x minus 4. So there's quite a few constants involved in this. We're just going to start with the vertical. And also we've got the amplitude, which is the 2. Okay, so the -4 means it will shift down 4. So let me just start by just doing this. Okay, so we're going to draw a normal sine curve between 2 and -2. And what we're going to do is we're going to shift it down to 4. We'll move that over a little bit. And it has an amplitude of 2. So it's a sine curve, it's got to start in the middle and go up, down, and again. So at the moment that's pi on 2, pi, 3 pi on 2 and 2 pi. Okay, that's step 1. Step 2, I've done the amplitude, that's already done. So make sure the amplitude equals 2. That's above and below. Y equals -4. Okay, so the next thing. You have to dilate by a scale factor of 3, a third. So you're going times 3, times 3, times 3, times 3. The 3's cancel. So you end up with pi on 6, pi on 3. This one would have been pi on 2, and that one's 2 pi on 3. Okay, can you see the period is 2 pi on n for a cos graph? So it'll be 2 pi on 3, which makes sense with this graph. Okay, so now what I'm going to do is just give you one where you actually shift it. So let's go 2x plus pi on 2 plus 1. Okay, so the plus 1 here, which is this one here, just means that you shift up 1. Okay. The 2 in front of here, so that 2, so the 2 means that is the amplitude. That's how far above and below 1. In saying that, if you're at 1 and you go up 2, you're at 3 and down 2, you'll be at -1. So that's actually your range. It'll actually range from -1 to 3, because you've got to go 2 above 1 and 2 below 1. Okay, the -2 just means it flips in the x-axis. So far, if we're looking at this, the first thing we do is we draw our cos curve. Okay, so 0 to 2 pi. And we can put all those things in. Okay, so -1 to 1. Then, once we've done that, we need to make sure you got the amplitude in. And we've got the cos thing. We need to flip it as well because it's a negative cos, so it's like that. So it's 2 pi and pi. Okay, now we're going to do what's inside the bracket. That's all this here, the 2x plus pi. So first of all, the plus pi on 2 means that you move to the left, the opposite direction, pi on 2. So if I take this graph and I move it to the left, this one here will go to there, that one there will go to there, that one there will go to there, and this one goes, we're just going pi on 2 to there, and that one goes to there. Okay, so that means that this one went to there, didn't it? It will look like this. You can kind of just get the pattern then. That's the blue graph. So the blue graph so far, because I did flip it, is -2 cos x plus pi on 2. Okay, I haven't added 1 yet. So the other thing you could do is you could move it up 1. And then the other thing you could do is you could dilate by a scale factor of half on the x-axis. Okay, so it's got to go up 1. So it's the same graph. Just has to go up 1, and it goes 2 up, so it's 3, and 2 down, so that's -1. And it is a negative cos, so it's looking like this. And that one's pi on 2, pi, 3 pi on 2, and 2 pi. Now, we do have a little bit of a problem here, because what we now have to do is we haven't done the 2x in front of that there. So we shifted it to the left, pi on 2, then we have to dilate by a scale factor of 1/2 on the x-axis. So if I was doing that, that would end up being like that. So this is pi on 4, that one's pi on 2, this one's 3 pi on 4, and that one there is pi, and that's your graph. Now I just want you to note that, say you were doing sine 2x minus pi on 3. Well, 3 is not very good actually, it's usually only ever like that. Then with this one, you could, if you were doing that horizontal shift, you could move right pi on 2 and then dilate by a scale factor of 1 on 2. Because if you did 1/2 times pi on 2, you'll get pi on 4. So that would mean you move it to the right, and then you have to divide by the 2 to get the x. So if I take this graph, the sine one, here's the normal sine one, that's 2 pi and pi. So am I going to move it to the right? So I'll do this in a different colour. So that will go pi on 2, this one to there, that one to there, this one to there. So we'll go like that. Okay, so I've moved it to the right pi on 2, and then I have to dilate it. So I have to divide everything by 2. And that one will just be pi. Okay, I also, that's all I've got for that one. I don't need to shift it anywhere, because, So the actual graph, it doesn't need shifting, does it? So the actual graph is like that. And just that's pi, and that's pi on 2, etc. And it will go between 1 and -1, because that's the number I've got in front.